So here, if you rewrite it, what would it be? 2x to the, you add the exponents, right? Yeah. 2x to the 3 halves, like that. Okay. So then if you get the antiderivative, what would you get? 2 times x to the 5 halves, right? Over 5 halves, but it's easier multiply by 2/5, right? Okay. And then that's going to be evaluated from 4 to 9, right? Does that make sense? Okay. So then what is this equal to? So this is 4/5. And then I'm just going to factor that out of the whole thing. So then it's going to be 9 to the 5 halves minus 4 to the 5 halves. Okay, now practically speaking, what's the easiest way to evaluate 9 to the 5 halves? So the 5 means raise it to the 5th power. The over 2 means get the square root, right? Well, you can do it whatever order you want, so which one makes more sense? Yeah, take the square root, right? So this would be the same as 3 to the 5th power, right? What's 3 to the 5th power? 243, yep. Minus, this is 2 to the 5th, right? 2. And so then 243 minus 32? 211 times 4? Over 5, right? Does that make sense? All right, what did you guys get for the first one? 1. Okay, what's the antiderivative of secant squared? Tangent. Valued from 0 to pi over 4, right? So this is tangent of pi over 4 minus tangent of 0, which is 1 minus 0, or 1. What about the second one? What's the antiderivative of 1 over 1 plus x squared? Yeah, that's inverse tangent, right? Or arctangent? So, okay. What's arctangent of 1? What is it? Pi over 4, right? You just said we just did it. Isn't it pi over 4? So tangent of what angle equals 1? Well, it's the one we just did right there, right? Minus, what's arctangent of minus 1? What is it? Yeah, negative pi over 4, right? Which is then pi over 2, right? Does that make sense? Okie doke. All right, what about the next one? That's arc sine, right? Arc sine or inverse sine. So inverse sine of x evaluated from 0 to 1 over root 2. So we have inverse sine of 1 over root 2 minus inverse sine of 0. So what's the inverse sine of 1 over root 2? One over root 2. If you rationalize, it's also known as root 2 over 2, right? So it's going to be pi over 4. Yep. So pi over 4 minus, what's inverse sine of 0? 0. Yep. So we get pi over 4. All right, what about this last one here? What do you guys think? So the first one is 1 over root t. Do we have a quotient rule business of any sort? Do we need a quotient rule business? No, right? How should we think of it? Well, yeah, 2 integrals, but I guess, whoa, sorry. Specifically, I mean just that one. 1 over root t, what should we think of it as? Yeah, t is t to the minus 1/2, right? So that then we can just use the power rule. Does that make sense? Okay, so then what would that be? What would the antiderivative be of the first one? T to the... T to the 1/2, right? Or square root of t? Whichever way is fine. And then, but what am I missing? Divided by a half or multiplied by 2, right? Okay, good. And then minus, so it's going to be t to the 3/2, yep. So it's 1/2 now, right? Add 1, you get 3/2. And then times 2/3, but I already have a 3 there, so then what is it going to be? 2. Does that make sense? Okay. And then this is going to be evaluated from 1 to 4. So this is going to be 2 times 4 to the 1/2 minus 2 times 4 to the 3/2. And then minus 2 times 1 to the 1/2 minus 2 times 1 to the 3/2. And again, like I said earlier, just be careful with your signs. It's okay if you go a little bit quicker. Just make sure to be careful with them. Basically this right one, right? Because you have minus whatever you get from there. So make sure you distribute it properly and whatnot. So here, what do I get if I have, so square root of 4, which is 2, times 2 is 4, minus, what's 4 to the 3/2? Okay, times 2 is 16, right? And then minus 2 plus 2, right? And what is that? Negative 12. And what does it mean that it's negative? Yeah, there's more area below the x-axis than above the x-axis. That's why it ended up being negative. Or all the areas below the x-axis, maybe. Because remember, the integral is the net area. So whatever you get, if it's positive, that means that there's more area above the x-axis. If it's negative, there's more area below. Does that make sense? Any questions?
So if that initial function is velocity, the negative 12 would be negative 12 as the distance traveled?
The displacement. Yeah. Right. Yes. Yeah. So there's more than one interpretation of the integral. It depends on what the function represents. I just find that thinking of it in terms of velocity and distance makes it easier to understand at the beginning, especially. But later on, we'll throw in some more because, for example, when we saw the derivative, we saw velocity, but then we also saw all kinds of other rates of change, right? We had population growth and how fast the water is flowing and all this stuff. And so you can think of the integral in all those different ways as well. So if you just think it more generally, then there are other interpretations. So it depends. So since you mentioned it, might as well. And we have a little square here to make a mini example. Let's say hypothetically you had this function, and let's say this is rate of water flowing out of pipe in, let's say, I don't know, liters meters per second, something like that. So notice instead of velocity, it's just, the rate of water flowing. So if I find the area here, what does that represent? Yes. So those are the units, right? Liters what? Yeah, the liter. So the amount of, so the units are liters. That tells you a lot, right? So it's basically the amount of water that flowed out in that time interval that you're talking about. Does that make sense? So then instead of velocity and distance, it's rate of change of water and the amount of water. And you were exactly right. I mean, looking at the units, the liters told you pretty much what it is, right? So immediately if you, if you just look at that unit, liters, even if you don't know too much about it, you can kind of think, okay, well, you have a certain time interval. That's the x-axis, right? The horizontal axis. And then if I think of the rectangles and all that stuff the same way, you multiply seconds times liters per second. What do you get? Liters. Well, what is that? Well, that's volume. What does that represent? Well, obviously it's in that time interval, whatever it is that's going on, right? So in this case, what's going on is water's flowing out of some pipe. I mean, I just made it up, right? And in the other one, we had velocity of some rabbit. But just by looking at the unit, you can tell, exactly what that area represents, right? Just cool stuff, right? I mean, pretty cool stuff. Okay, all right. So how about, okay, so let's do a little bit different example. Let's say you wanted to find, for example, won't be too hard. Let's say this integral, minus 1 to 1 of the absolute value of 2x minus 1 dx. Okay, so you have to be a little bit careful with absolute value because we don't really have antiderivative rules for absolute value functions. But do you remember what we did when we had an absolute value function and we needed to either find the limit or find the derivative? We rewrote it as a piecewise function, right? So it's the same exact thing, that you need to rewrite it as a piecewise function so that then you can figure out what the area is in this case. Yeah? Does that make sense? Okay, so let's do that. So over here, let's see, maybe, well, I don't know. Yeah, I'll just do it down here. Okay, so the absolute value of 2x minus 1. So what is that equal to? So it's going to equal to 2x minus 1 or minus 2x minus 1, right? This is always how we break up our absolute value functions into piecewise functions. And so maybe it's been a while, so I'll do a quick refresher. So what goes here? What interval goes there? It's whenever 2x minus 1 is already greater than 0, you're going to use the positive one, right? Okay, so then what is that? If I solve for x there, x is greater than a half, right? And what about this one down here? It's whenever 2x minus 1 is less than 0. That's when you use the minus 2x minus 1, right? Because if it's going to be negative and then you minus it, what's going to happen? It's going to make it positive, right? So that's the idea, just in case you guys forgot. So basically when x is less than a half, right? All right, now can x equal to a half? Sure it can. You just get 0, right? So which one should I put the equal sign on? Either one, right? So it doesn't matter. So I'll just put it on that one. But it's 0 on either one, so it's no biggie. Okay, so what does this mean? Well, this is, so what you do then is you break it up into two integrals. One from, and so here notice we're using that property, right? So remember we said, so like here's -1 and here's 1, right? What am I doing at +1/2? I'm going to split it up basically into two intervals, right? So I'm going to get the integral from -1 to, so from -1 to 1/2, right? And then I'm going to add the integral from 1/2 to 1. And the sum of those two is going to give me the entire integral. Does that make sense? The idea? Okay, now I'm missing the functions in there. Which ones do I put where? From -1 to 1/2, which one would I use? -1 to 1/2, x is less than 1/2, right? So I did the wrong color there. But so it's going to be minus 2x minus 1. I just put the negative on the outside, but you don't have to. It doesn't really matter. You can leave it in if you feel like it. And then from 1/2 to 1, which one am I going to use? I'm going to use 2x minus 1. Does that make sense, how we broke it up? So you break it up into a piecewise function, and then depending on where each function is defined, you rewrite the integral into two or more. Sometimes you need more than two. Any questions about that? Does that make sense? Yeah? Okay, so let's see here. So now what? Well, now we integrate, right? So let's see. So what do I get? What's the integral of the first one? 2x squared over 2 minus x. This is evaluated from -1 to 1/2. Yes or no? Okay. What? Thank you. Did you guys see that? Should be minus, no? And plus, yeah. Because we have this minus sign out here. So again, just be careful with your signs. Okay, and then, all right, so what about the next one? So plus x squared, right? Minus x, and this one's going to be evaluated from 1/2 to 1. All right, so questions so far? We doing okay? All right, so then what is this equal to? This is minus what? 1/4 plus 1/2 minus -1 minus 1. So that's just the green one, right? So that's that first integral. And then in the purple, so this is going to be plus, I'll just write it on the next line. So plus 1 minus 1 minus 1/4 minus 1/2. All right, so notice it's very easy to make a little mistake right there, right? You guys agree? So there's a lot of little fractions, a lot of little signs, a lot of stuff. So just be careful. Let's see. So what do I get? So minus a fourth plus a half. So that's going to be 1/4. And then what else? What's the next one? Plus 2. Good. The next one? Plus 0. Good. And then? Plus 1/4. Yeah? Because it's minus a fourth inside the parentheses, but then there's a minus outside. So then what is that? 2.5. 2.5. Also known as? How many halves? 5 halves. Does that make sense? Yes, maybe? A little bit? So here if I look for the very first one, so 1/2 minus cosine x, so here I'm looking for this one, right? So 1 is cosine x less than 1/2. Well, when is cosine x equal to 1/2? At pi over 3. Okay. So that's good. So then cosine x is less than 1/2. 1x is less than pi over 3 or greater than pi over 3? Greater than pi over 3, right? So it depends on how you want to look at it. But for example, if you're thinking of the unit circle, so you're right here in the first quadrant, right? So cosine x is the x coordinate, right? So this is 1/2 here when the angle is pi over 3, right? And so notice if I go this way from pi over 3 to pi over 2, the x value is getting smaller, right? It's going from 1/2 to 0. And then it's when x is less than pi over 3 that cosine x is greater than 1/2. Does that make sense? Yes? So if I break this up, what do I get? I get the integral from 0 to pi over 3 of which one? Which one do I use from 0 to pi over 3? Yeah, the bottom one, right? Minus 1/2 plus cosine x dx. And then plus the integral from pi over 3 to pi over 2, this time 1/2 minus cosine x dx, right? Does that make sense? Yeah? Okay, so let me, well, no, I'll just leave it there. I think, I'm just not sure if I can fit it all in here, but Maybe. All right. So what do I get? I get minus 1/2 x, and then what else? Plus or minus sine x? For the antiderivative. Plus sine x, right? So plus sine x from 0 to pi over 3. And then plus 1/2 x minus sine x from pi over 3 to pi over 2. Okay, so what does that equal to? So that's minus 1/2 pi over 3 plus, what's sine of pi over 3? Root 3 over 2 plus 1/2, or sorry, not plus, minus minus 0 plus 0, right? Because sine of 0 is 0. Okay, and then plus, let's see, 1/2 times pi over 2. Minus, what's sine of pi over 2? 1, right? Minus 1/2 times pi over 3, which is pi over 6. Minus sine of pi over 3, which is? But this one should be plus, right? So far, so good? Okay, so let's see. What can we simplify here? So we have minus pi over 6 and then minus another pi over 6. So that's minus pi over 3 and then plus a pi over 4. So what's pi over 4 minus pi over 3? Well, I'll just write it down like that. Okay, and then plus, we have root 3 over 2 plus another root 3 over 2. Well, that's just root 3, and then minus 1. So what's pi over 4 minus pi over 3? How many pi over 12s is that? 1 or minus 1? Minus 1. Minus 1 pi over 12 plus root 3 minus 1. All right, did we make any mistakes? Well, I don't know. Maybe. So you got to be careful, right? You got to be careful. Okay, well, have a great night. Practice.